Alright, so yesterday we were talking about inverse functions, and we were talking about corresponding points, right? So if you have a function and it has an inverse, right, its opposite point is going to be on the inverse, right? And we kind of did from first example, right? So if I have kind of a tangent line going through this point here at 1, 0, its corresponding point is just the opposite of that. So that would be 0, 1, right? So if I have a tangent line going through this point, right, say, for example, that the slope here, say, was 2, right? So this line here has a slope of 2. So m equals 2 at 1, 0. So anytime you have a regular function and its inverse, and they have corresponding points, right, they're kind of reflected over that y equals x line, this slope here is just going to be the reciprocal of this slope here, right? So the slope then of this line going through 0, 1 would be what? 1/2, right? So then slope is 1/2 at 0, 1. I just made it up. But big thing you just have to remember from inverse functions is if they have corresponding points, right, their slopes are just reciprocals to one another. So if this is positive 2, this is positive 1/2. All right, and what that looks like with kind of calculus notation. Again, you guys will see that like in a multiple choice question. F of g of x is equal to x, which is equal to g of f of x. So all this is saying is that f and g are inverse to one another. All right, and then the next part, they'll usually like give you a point. So if f has a point at a comma b, then g has to have a point then at b comma a. Right. Yeah. So if I wanted to figure out then the slope at this term right here, all I would have to do is then figure out the slope of f at this particular point and then just figure out its opposite. All right. So again, if I have a point here at, say, 1, 0, and the other point is at 0, 1, and if I know that the slope for my original function is, say, 2, then the slope here is going to be 1/2. They're just reciprocals. That's all. All right. No. So like tangent and normal, like perpendicular lines are opposite reciprocals. So you like flip it and then also make it negative or positive. Okay, so I have x cubed. We're saying that it's 1 to 1. All right, so that means every x goes with 1y, every y goes with 1x. Looking something like that. All right, so it says find the following. So we have f of 2 is what? F of 2 would be 8, right? So that means that f has a point 2, 8, right? So since f of x is a 1-to-1 function, that means I can find an inverse for it. So I don't know what it is yet, but what do I know the inverse definitely has a point at? Right. So kind of get into the habit of when you see a inverse function question, kind of get into the habit of writing this down. You know, it has a point here, so its corresponding point must be at 8, 2. Right, but I mean, this is like a multi-step question, but like if you look at like number 5 on the next page. Like that would be a multiple choice question, number 5. All right. All right, what is the derivative of f? Nice. And then what is f prime of 2? You know f prime is 3x squared, and then what's f prime of 2? You take the derivative of x cubed, right? So then, right, you get 12. Good. All right, so the slope there at 2 is positive 12, right? So if you have a point, say here's 2, and say that is like 8. So the slope of that line like that would be 12, right? All right, now it says find the inverse of f. So I know that f of x is equal to x cubed, right? Which is the same thing as y equals x cubed. Now, how would I find the inverse? X equals y cubed. You're close. Right. So you have the cube root of y is equal to x, and then just switch x and y. So you have cube root of x is equal to y, so the cube root of x is your inverse. Say again? Because you want it in terms of x, not in terms of y. So whenever you're finding an inverse, you're going to solve for x. So take the cube root on both sides, right? I've solved for x now, and then once you get to that, you just switch x and y back. Here. This is in terms of y. You want it in terms of x, right? Because now this relates to this function. All right, so this is the inverse to x cubed, right? So if I cube something, and just to undo that, you just take the third root of it. Okay, so what would the derivative then be of the inverse? Say again, Kel. Okay, good. So that gives me 1 over 3 cube root of x squared, right? You can either put the squared here inside, or you can put it on the outside. Doesn't matter. All right, so that's the derivative. So what then is the derivative there at 8? We have 1 over 3 times the cube root of 8 squared. What do you get? 12, right? Good. Now, what also do you get as 1 over f prime of 2? 1 over what? 12, right? So as you can see, we kind of did you get the same thing. All right, so a lot of times, like, you won't be given a function to kind of help you figure this out. So it is more useful to kind of use just the original function and its derivative to figure out just the reciprocal slope of one another. So you, where? For f or g? G? So we figured out from the part above, right, that f prime of 2 was 12, right? So then the reciprocal of that is just 1 over 12, right? So we figured out that there was a point at 2, 8, and then its inverse has to have a point there at 8, 2, right? And then we figured out that the slope at 2 came out to be 12, right? So then the slope of the inverse is just the opposite, is the reciprocal of this guy, right? So that'd be 1 over 12. So really all you need is kind of this point and then its derivative to figure out the information. Okay. All right, so you have x to the 5th plus 2x minus 1. Use f prime of x and the continuity of f of x to show that f of x is 1 to 1. Okay, so f prime of x would be what? Okay, good. Now, what do you know about like all the y values that you get here? What are they always going to be? Positive, right? So if your derivative is always positive, that means that this function here is always going what? Always going up, right? So this is greater than 0 for all x. So this means all x in the set of real numbers. So this means that your derivative is positive for all values of x in the set of real numbers. So you have your derivative is positive for all values of x in the set of real numbers. Here? Yeah, you do 2 lines and then you connect it like that. All right, so again, your derivative is positive for all values of x in the set of real numbers. So we're trying to show that this is 1 to 1. So we want it to be first a function, and then we also want it to, we don't want any y values to repeat, right? So if I have like an x squared graph like that, right? I know that like this y value right here repeats at 2 x values, right? Right. So they say this was like 5, right? Y equals 5 is here, and it's also here. We don't want that. We want a graph that more looks like that. Right? So this means that every y value as you go along the line has only one x value that it goes with. Well, it's next to the 4th, right? So that means that, again, even if I plug in negatives, I'm going to get a positive number. Again, we're trying to show that this graph kind of just goes up like this. It just increases. Yeah, but as you read the graph from left to right, your values are increasing as you go, right? Okay, so we can say that f of x is strictly increasing. What was that other word that we can say instead of strictly? Remember? No. Monotonically. Alright, you can use, they both kind of mean the same thing. So f of x is strictly increasing and continuous. Polynomial. And all polynomials are continuous. Alright. F of x is strictly increasing and continuous for all values of x. Not yet, no. So f of x is 1 to 1. Are you happy now? Alright, so now, because f of x is 1 to 1, we can now find its inverse. If it's not 1 to 1, we can't find its inverse. Like this graph here is not 1 to 1, so I can't find an inverse. But because it's in like an odd power here, that means that it is going to be 1 to 1. Kind of looking at the graph, we figured out that the derivative is always positive, so that means it's always going upwards. And then, right, yeah, that could, yeah, it could work either way. And it also says it's because it's a polynomial, it's a continuous function. So there's no like asymptotes or anything like that going on. The original was a cube? It's always positive. Then it wouldn't be. Then we would, right. Yeah. So you gotta show that it's kind of going in the same direction, so it's always going up or it's always going down. And then you also need to show that it's continuous. If it's not continuous, then it's not going to be 1 to 1. So you just kind of have to know, you know, the different like continuities of different functions. So kind of, yeah. Not all of them, but most of them. Yes. Okay. You could say that would tell me that the original function is not strictly increasing or decreasing. So that means it would probably go from decreasing to increasing. So then I can't find f of x is not 1 to 1, and I can't find its inverse. Yes. Yes. Correct. Right. All right. So what would f of 1 be? Yep. 2. Okay. So I know that f has a point at 1, 2. So that means that its inverse has a point at 2, 1. Okay. All right, now it says find the derivative of the inverse at 2. All right. So we know that the inverse has a point at 2, 1, right? So if I figure out the slope here at 2, it's going to be the same thing as 1 over f prime of what? What was the corresponding point with the original? 1, right? Good. Now all you need to find is f prime of 1. So f of x we know, or f prime of x, we know is 5x to the 4th plus 2. So f prime of 1 is 7. Yeah, it came from like this point over here. So if I want to figure out the slope of this function at 2, I need to find the slope of the original at 1 because they are like opposites to each other. If you plug in 1 into the original, you get 2. Yep. And again, you just switch these points here. All right, so we figured out that the slope of the original at 1 was 7. So then the slope of my inverse at 2 is just the reciprocal of that. So it's just 1 over 7. Yep. So that is the slope of the inverse at 2. All right, so what do you need to do? You need to find point on f of x and corresponding point on the inverse. And then usually find f prime of x at say original point, and then find reciprocal to get the inverse's derivative. This here, that is the derivative of the inverse, or the slope of the inverse. All right, so you have f of x. What's f of 0? F of 0 would be 2, right? So that means I have a point there at 0, 2, and that means that the inverse has a point where? 2, 0, right? All right, so we found f of 0 is 2. Now, it says they have to find the derivative of the inverse at 2. Now, what is that going to be the same as? you just need f prime of 0. So f prime is what? Okay, and then f prime of 0 is 3. So, okay. All right, so you have f of 0, right? You just plug in 0 into the original, right? We got 0 equals, comes out to be 2. So the original function has a point at 0, 2. So its inverse, its corresponding point, is just the opposite, 2, 0. So it's going to be since it's the inverse, we want the reciprocal slope at its corresponding point. Right? So we can figure this out. Right? That would take a lot of math. We don't want to do that. So again, figure out the slope here. It's just the reciprocal slope of this point here. This is easy to find. Right? So we can find this and then just find its reciprocal. So I found the derivative, plugged in 0, and got 3. So since this slope here is 3, the slope at its reciprocal point, which is here, is that. Right? So they're opposites of each other.